I have a loud voice. Welcome everyone. We organized the Minimalism Dev Room, and there have been some very interesting talks. I'm going to take a slightly more generic approach and discuss why we set up the room and why minimalism matters in our opinion. So the crux of the matter is that to really trust systems, we need to understand them, right? And these days, even the Debian Bootstrap is 350 megabytes of binary blob. Did you know that? And it includes the GCC compiler and a host of other tools. So how do we really know what's in there is secure? Also, typically these days we are downloading 1 gigabyte Docker images, and if you try to do a post-mortem on them, it's very hard to find out what's actually in there, right? I mean, you can find what is in there, but how was it built? How was it created? How are you sure, that there's nothing untrustworthy in there? So are we driving on luck alone? Are we getting away with murder? I think the answer is yes. So what is minimalism really about? It's about things being simple, being transparent, where the dependencies are really clear, where you have clear APIs, you have well-defined behavior, and especially, the stuff should be easy to understand and read. How much of our software today actually matches these criteria? None, as far as I know. Well, maybe some scheme programs. So.
And it should also not be bigger than necessary.
Yeah, minimalism. Yeah, so.
Does project success? Let's try to read these criteria, and I think they're doing it quite good.
Yeah. So the Heartbleed disaster you've probably all heard about and maybe looked into because it hurt almost everyone. Cisco system identified 78 of its products as vulnerable, including IP phone systems and telepresence video conferencing systems. It cost millions of dollars, which I guess is an understatement. And the truth of the matter is it's an open source project, and at the time there were only 2 people working there on it, and it has 500,000 lines of code, right? And what actually happened with Heartbleed is there was some code left in there which was not supposed to do anything, right? I mean, it maybe was supposed to do something, but it was really just left in there and nobody looked at it again. And it was the problem. So how many lines of source code do you think there's in the Linux kernel and drivers today?
24 million.
All too low. How much is in Windows? Even more. OS X, Android, 20 million. Mozilla.
What's level? Firefox?
Yeah. Facebook, their code that they use. I have the answers. So this is the Linux kernel. It's grown a little bit over time. So it's now close to 30 million lines, I guess. Oops, sorry. 25 million lines of code, including drivers. And you can see how it's grown since a really small print. I can't really read it anymore, but just in a few years, it's gone from 5 million. Browsers. Yeah, so almost 37 million lines of code in Firefox. That is more than Linux. Seriously. And I mean, at the time, remember when Microsoft was really worried that the browser would become the desktop? We've done it. And it's C++ too, right? Scary. So Windows, there are 50 million. OS X, that's not officially known. Android, sorry, it's only 12 million. Android is only 12 million. And then Facebook apparently has 60 million lines of code to run, everything. How many transistors do we have in a CPU today? Billions. It's scary. Yeah, so the original 83, 86, which I used to program, and I also did the Trash 80, by the way. Yeah, so it had under 300,000 transistors. Then it went in 2007 to 400 million. Then in 2014 we surpassed the billion mark, and today we are at sort of close to 20 billion transistors. ARM, is it simpler? That's what you'd hope, right? Finally we get a new architecture, it's going to be a lot simpler, right? 8.5 billion, so it's less than the AMD, but yeah, I think actually for what it offers it's more. Let's discuss the Intel Management Engine for a bit. You are aware that every CPU produced since 2008 contains a full operating system, hardwired on the chip, yeah, and it's Minix. Minix? Any Linux users here today? Minix, right. So, and they found weaknesses in it, right? In 2017, and this is an exploit that goes back all the way to 2008. And a normal user cannot disable the management engine. This is actually the last line of computers you could disable it. It's a 2011 one. It's not strange I'm using it. You can read about it on Wikipedia. So Intel claims it's a good thing. They have the management engine. They give a service to corporate customers. They can actually get network access on the CPU. But we don't really know what it does, right? So, I plugged this from the internet. Oh, sorry. It can read any byte in RAM. It can send data to the network interface. Communicate with the operating system. It could be abused, right? Could be. We trust Intel. We all do. And Tannenbaum, Intel, fired a host of questions to Tannenbaum at the time they were introducing Minix on the chip, right? And he didn't know what it was about. So for the record, he says, if I had suspected they might be building a spy engine, I certainly wouldn't have cooperated. AMD any better?
No.
No. They actually have a management engine, and we know nothing about it. Yeah. You can check this right up by someone. So Minix itself is minimalistic. It's about 4,000 lines of code, they claim, for the kernel itself. It's a microkernel, and they think that within these 4,000 lines they can eventually make it bug-free. They're not stating it's bug-free now, but small helps with minimalism, right? And that's also why probably Intel put it on their chip. It's ironic. So when it comes to minimalism, we really are talking about simple components and composability. How do these components fit together? And the Unix philosophy, the original one, I'm not talking about systemd here, they have this. That served us well, right? So we have Janneke here, who is working on GNU-MES, which is replacing that 350 megabyte binary blob. And he wants to reduce it, or the team wants to reduce it to 500 bytes of binary blob. Well, that would be an improvement, no? And it will affect all Linux distributions. So this is also about components and composable, and also about readable.
What is this 300 binary blob?
It's got a GCC compiler in there, bin utils. Jan?
So it's a distribution.
Yeah, it's a small distribution itself. It's used to, because to compile Debian you need to compile something, right?
Yeah, so it's Debian problem basically, because our Linux is already 5 megabytes. So.
Yeah. But this is what Debian does, and the others are no better. The Herd, another group, the GNU projects, currently at 400,000 lines of code, so it's not minimal, but it's a microkernel. And it aims to surpass the Unix kernel functionality, security, and stability. So what it means, security, it has to be more composable and more components, componentalized, what is the word? And composable, right? So while the GNU Herd is not a very active project today, you can see that in time it could become important. GNU Geeks, anyone heard of GNU Geeks here today? Yeah, so this is another attempt at, making things in smaller components and making them composable. I'll say a bit more about that if I have time. Sorry. So is this minimalistic? So this is a billion transistor chip, and it looks like they're components, and that it's it certainly probably is composable, but no one today can understand what's really there. It's all done by machines. But also it is actually pretty complex. I mean, if you look at the street map of Brussels, yeah, it also looks like it's components. There are houses there, and there's an API. They're functioning together. But what's really happening at that level? We have no concept of understanding anymore, right? I mean, never really had when we left villages, small villages. So modern CPUs actually look like city maps today. Many components. They look composable, but they're actually complex. And we rely on that technology throughout, right? That's why this Huawei stuff is such a concern. This is a graph, and the graph is a dependency tree from GNU Geeks. So this shows Python with its dependencies. Sorry about this small size. I probably have it open somewhere. Yeah, there you go. Yeah, so if you zoom in a little bit, you can see how it all hangs together, okay? So this is your typical stuff that you run on your computer. Switch. Are they components, these individual pieces of software? Well, this is a graph, and it looks like it's components. These are not components really. These are components of software, but how they really interact with each other, we don't know, right? We only can show how they depend on each other. So the outcome, what we are running on our systems is not really component. It doesn't consist. I mean, it consists of components, but they're not understandable components. So one thing you can improve things to make it more minimalist is say, okay, when I need something to run, I may create a container or a computer which only has the software on it that I actually need to run it, right? So you take the graph and you reduce it. Yeah, if you take a typical Debian distribution, there'll be a lot of installed pieces of software, and you may have never even run, right? But to make it more minimalistic, what you could do with GNU Geeks, and it allows for it because it controls the dependency graph, is to say, okay, I'm going to create a container, and I'm only going to put the software on it that I need to run my service, right? And this GNU Geeks makes it reproducible, but also minimizes the attack surface. And in a way, for embedded systems, it could be redefining the future. So the message really is that things should be simple, transparent. There should be clear dependencies, clear APIs, well-defined behavior, easy to read. We should aim for that in an ideal world. So why do we want minimalism? To avoid dependency hell, I guess. Backdoors, spying, malicious intent. In a nutshell. Questions?
Why do you think software seems to evolve towards the more complex? Because it sounds like simpler could be simple to make. But
yeah,
it's not how it goes.
Complexity sells better. That's the reason.
Yeah, well, maybe that's...
There are many reasons, I think, but because we can, is one word.
It can be interesting to make complex things.
Because we can. I mean, if you think about the language like Go with all the dependencies and the modules that they pull in, they're typically hundreds. Or JavaScript is also an infamous one. Joe Armstrong, who created Erlang, he claims that he always avoided dependencies. Yeah, so for the Erlang compiler and environment, and he says, that's the reason why it's still running today, or most of his systems are still running today. And there's something to be said for that. Yeah, how much time do I have?
5 minutes. Maybe the next speaker could already.
Yep.
May I add something to your question? It's also from education. I'm from a city in Prague, and I can say that no one teaches students about problems of complexity, how to deal with complexity. There's no this talk at all, and I saw it on myself that I learned this from practice in open source, but most of the colleagues never learned it. And they work in some corporates, and they built all the stuff, all the complex stuff, and don't understand what the problem really is. So this is each part of the problem.
Yes.
Of education.
Yeah, so could you comment on this quote from Emily that you mentioned, which is for every problem, there is a solution which is simple, clean, and wrong.
I'm no philosopher. Yeah. Gary? For every simple thing or solution?
For every simple problem, there is a solution that is simple, clean, and wrong.
Yeah. Simple, clean, and wrong. Yes. It's it's really a complex topic.
I think the point is that simplicity by itself does not guarantee that it's correct.
Yeah.
So how do you prove that something is correct?
Yeah. That's a whole area of research, an active area of research, in fact. Yes. Yeah. Are you ready, Hisham? Is it working?
Yes.
Okay. Jelle?
So what do we do?
Well, we should aim for simpler hardware and simpler software. Yeah, and with software we can already do a lot. Hardware is going to be a different story for the time being. But I think if open and free hardware platforms come along that are affordable and almost are fast enough to beat my 11-year-old computer, we'll take them. I'll take free hardware. Yeah.
Aren't you using minimalism as a cheap alternative to proper design? Like the one way to do a proper design is to do a minimal design, but it's not necessarily a good solution. So
There are trade-offs, Yeah, so minimalism, there are trade-offs for sure, and companies will, Microsoft will not opt for minimalism, nor will Google. Yeah, but I think for ourselves, we need to drive for it hard. And when a phone comes along, which is free hardware and it has a relatively simple operating system and free software, some people will opt for it, and get more privacy out of it. Yeah.
I'm wondering if you have how you measure complexity kind of empirically. I mean, when it's easy to say, okay, a million lines of code must be complex, but if they're all doing something and the dependency tree is simple, like how do you measure? Is there some property of the dependency graph you can measure? Can you map that? How do you measure complexity?
How do you measure complexity? It's a difficult one again, and it also depends on what you are trying to create, right? So, we are dealing with complexity in many ways, and it's an active area of research also. Yeah, I think with computing we are going a little bit off the rails lately. Yes, Mark.
Isn't it like a bit like evolution? I mean, if you look at the software which survives as the fittest, and you compare it to organisms, they all have DNA which junk all over the place, and the software is the same basically.
Yeah. So yeah, actually nature is highly efficient. It gets rid of junk.
Yeah, but it takes a long time.
It takes a long time, yeah.
So I think we also have a very nice tool in computer science, which is layers of abstraction.
Mm-hmm.
In other words, when I look at this screen, for instance, there are characters on it. I don't think they are pixels. That someone had to think about drawing the pixels. I don't have to think about SQL.